Okay, so we're looking at 4-7, and we're almost actually done with the chapter already. We're going to take our test next week, Friday, I'm guessing. I'll put that up later. So next Friday will be a test over everything on chapter 4. I think there's one lesson that we skipped, and I'll make that clear. Yes. Okay, so using the least common multiple. What is a multiple? I got to know what that word is. I know what least is, right? I know what common means, and that refers back to GCF. But I need to know what multiple is before I move on. Emma Grace, what is a multiple?
A number is a product of that number and any other number.
There you go. And it's right there on page 200. A multiple of a number is a product of that number and any whole number. You're like, huh? Let's just write that down. Let's see if we can figure this out. So the multiple of a number is a product of a whole number, or I guess I'll put of that number and a whole number. So it might be kind of confusing the way it's worded, but write it down and we'll kind of pick it apart, see if we can understand it. Scroll up here for some of you. There you go. So a multiple of a number is a product of that number and a whole number. Okay, so let's pick a number and see if we can explain it that way. Let's go with 2 and 5. So that's the ones they're giving us there, 2 and 5. Okay, I'm going to list out multiples of 2 and 5. The first multiple of 2 would be what?
2. 1. 0. 1.
Okay, I heard multiple things here. It's actually 0. You're like, wait, what? Okay, this is how you figured it out. Okay, it says a multiple of a number, so a number 2, is a product, so I'm multiplying something, of that number and a whole number. What's the first whole number? Jack?
1.
Not 1. There's one right before it. 0. So what's 2 times 0? 0. What's 2 times 1?
2.
The next multiple of 2. What's 2 times 2?
4.
Okay, do you see the pattern here? 6, 8, 10, 12, 14. And I'm going to put ... because I can't list them all out. In fact, how many multiples of 2 are there? There's an infinite number. I can't get to the last one, so that's why I have to put my ellipses. But you guys see, to get the multiples of 2, I start off with what's 2 times 0? 2 times 1. 2 times 2. And so on and so forth. So does 2 times something equal 14? Yeah, 2 times what equals 14?
7.
So 14 is a multiple of 2. Okay? 14 is a multiple of 2. Is 7 a multiple of 2?
No.
Okay, good. There's no whole number that multiplied with 2 will give me 7. Nope, not out there. So it would be 3.5, but that's not a whole number. All right, what's the first what's the first multiple of 5, Marissa? Oh, 0. Yeah, you're right. Oh, and then you're going to keep going here. How many are there? Infinite number. We have listed a few of them, but there are way more. Okay. If I told you to list out all the multiples of a number, how nice would that be? Some of you are like, yeah, it's Fun Friday, so we'll do it. Oh my. Oh, I hear requests here. Oh, really? Okay. Anyway, I'm going to save you from that. So we're not going to list out the multiples, but do we have any common multiples here? Can you guys tell me what the common multiples are? And I'll do this with a different pen. Yep. Common multiples. Yes, ma'am.
0.
Yeah, don't they both? And I'll box them in so it's like... Yeah, they both have zeros. That's a common multiple. Anything else? Caroline? 10 is a common multiple. Anything else that maybe is not up there? Just give me another one. Don't go too far out. Yep.
20.
Huh. 20? Yeah, 20's here. Would 20 be in this set? Yeah, 20 would eventually be here. Dot, dot, dot. And so they do share 20 as well. Okay, you guys see that? How many common multiples do they have?
Infinite.
If they have an infinite number of multiples each, then they also have an infinite number of common multiples. Ooh. Find me all the common multiples of these two numbers. Impossible.
Yes.
I can't do it. But there is one that I can find that is going to be part of this lesson. It's the LCM. But technically, what is the least common multiple of those two numbers? Technically. What's the least common multiple? Michael? 0. In fact, you know what the LCM of any set of numbers is?
0.
Yes! So the answer to all my problems are 0, 0, 0, and then 0, 0, 0. Okay, that would be awesome, right? That would be awesome. That would be awesome. But when we say least common multiple, we're talking about the least common multiple that is not 0, because that would not be helpful. Of course it's 0, but that is not helpful. So what's the least common multiple? Well, what's the least common multiple? Now, not 0. We know 0 is common to both, but we need a more useful number. John? 10. So the LCM, which is how you guys know it, the LCM of 2 and 5 is 10. Now, do you remember how I did that with GCF? And you don't have to write this for your answers, but I said the GCF of blah and blah is blah. Now I'm saying it with LCM, and I want you to see how it's written so you know how to read it and you understand what you're doing. I have a quick question, though. We just looked at GCF maybe 2-3 days ago, and now we're looking at LCM, and in fact, it seems like they're very similar, but they're not. And you guys should know this, right? But it's very easy to do this. GCF, LCM, and do this. Oops, I mixed them up. So I need us to clarify what the difference between multiple and factor is, because they are not the same. So this is what I'm going to do real quickly here with you guys, a little exercise. I'm going to take the number, let's go with 20. Can we just go with 20? So put the number 20 down, and we're going to do two things. We're going to list the factors of 20, and we're going to list the multiples of 20. We're going to do two things. And from this, I want us to distinguish what the differences are. Okay, what are the factors? Just list out the factors of 20. I don't want prime factorization. I just want this number is a factor, this number is a factor, and this is review. Yes, sir, John?
1.
1.
2. 4. 5. 10. And 20.
All right, would you guys agree that those are the factors? Okay? And then I need some multiples, because I can't give them all, but what are some multiples of 20? Can we do it as a class? Ready? 0. Next one?
2.
Sorry, multiples of 20. Wouldn't 20 be the first non-zero multiple? Because, ready? What's 0 times 20? 0. What's 1 times 20? What's 2 times 20? And the pattern continues. And I'll just go to 100. Dot, dot, dot. Okay, keeps going. Just from the lists, can anyone tell me what's a difference between the factors and multiples? Just from the lists. Yes, ma'am?
For multiples, 20 can go into each number, but for the factors, 20 can go into each number.
Okay, good. I like that. You see, for the multiples, can't 20 go into all of these, all the multiples? But can 20 go into any of these except for 20 itself? No. Okay, that's a good observation. Tristan?
The multiples are bigger numbers than the factors.
The multiples, other than 0, right? 0 is kind of that strange one, are all bigger. But what do they have in common? Like common of common of common? So what's common to even these? There's something in common. Braden?
20.
A factor of 20 is 20, and a multiple of 20 is 20, right? So this is what you need to do. Ready? And actually, this is the way, actually I should have done it differently, but I'll just do it like this, okay? A number. Just write the word a number, because this goes for any number, except for a prime number, but technically even a prime number. The factors are below it. And the multiples are? Above it. So these answers that we're going to get today should be above the number that you're given. For the G7, it should have been below the number you were given. Okay, so multiples are above, factors are below. And don't they both share? Isn't one multiple the number and one factor the number as well? So they kind of share that as well. So just a little pattern. So if you're getting your answers like, yes, I got them. The multiple of 20 is 5. Got it. Wait, 5 is a small number, so it can't be a multiple. Okay, so just keep that in mind. All right, let's actually work this out. Example number 2, we're going to find the least common multiple of 12a squared b and 8ac. All right. AC, yeah.
What is that, John?
Okay, quiet down, guys. Quiet down so we can work on this. Remember, you're not helping your cause right now. Okay, 12a squared b, 12a squared b, and 8ac. Okay, so I want to find the least common multiple, and we can actually deal with the numbers and then with the letters, but guess what I'm going to do on this problem? Just like I did with the GCF, I'm going to find the prime factorization. And does anyone know it of 12 already? Like you're getting good at it, you're like, I got it. 12. Michael?
3 and 2 squared.
Okay, and I'll put it 2 squared times 3. And then do you remember what this would be here?
8 times 8 times 3.
Okay, so this is review, and you did this on your quiz, and hopefully you did it well. I'll grade those this weekend. There you go. And then 2. Oh, wow. My words are not coming out the way. 8. What is the prime factorization of 8? Yes, ma'am? Elizabeth?
2 to the third.
And then times A times C. Not times G. Okay, anyway, here's my prime factorization. Now, do you think we're going to do it exactly the same as GCF? What do you think? Probably not, right? We're going to do it a little bit differently. We have to ask this question. I have to see how many unique factors it has and keep the highest number of those factors found in either one of these numbers. Did you get all that? Okay, ready? This is what I want you to do. How many unique factors are there? Well, I know that they have a 2 as a factor, right? I know that there's a 3 as a factor too. Is there an A? Is there a B? And is there a C? I'm going to use all of them as part of my multiples. But I have to find out what's the power. So this is what I'm going to ask. What's the highest power of 2 at either one of these numbers? What's the highest power? To the third. I'm going to use that. The highest power of it. 3. What's the highest power of 3? 1. So it's just 3, right? I'm going to keep 3 to the first, but you don't even have to write that. What's the highest power of A?
2.
A to the second. What's the highest power of B?
Me.
Sorry, 1. And C. So again, you could do 1, 1, and 1, but you don't have to. This number now multiplied together is going to give me the LCM. Okay? There are easier ways to do it. List them out. You could, but number 28 on your homework. That's not too bad, actually. Number 29. That could be kind of rough. It's easy. Oh my. Okay. Anyway, yes, you could list them out. You can always list them out, but this will always get, no matter how big the numbers are. Okay. So now we're going to multiply these together. What's 2 to the third? 8. All right. What is 8 times 3? And then to write the rest of it out, that's the LCM. Okay? And yes, there are easier ways. Some of these you can do in your head. But what are we practicing in this chapter? Prime factorization and how it relates to LCM, in this case. Now, what I'm asking now So look at my number, my answer down here. Is this number bigger and or smaller than these two right here? It's bigger. Is that LCM or GCF that's supposed to be bigger? LCM. This is what you're saying. This number right here is the smallest number possible that can fit both of these in it. Both of them can fit into, but it's the smallest one. 24a squared b c. Yes, sir.
You could have a GCF bigger than that, though. Like, you're just...
On this problem?
No, like, I'm just saying, like, in general.
Oh, yeah. You can have a way bigger, yeah. Depending on the numbers you already have. Yes. Okay, let's keep practicing. Let's do it with some numbers. Okay, go to page 202. Page 202. And let's just do it number 5. So let's do it with the number part, and then we'll get the variables again. The numbers are 10 and 14. And I want to find the LCM. And the question I'm answering overall is, what's the smallest number, the least number, that can fit both of these into it evenly? So prime factorization, what's 10 prime factored? 5 times 2, 2 times 5. Okay, good. What's 14 prime factored?
7 times 2.
Yeah, and I'll put it in order here just to make it easier to look at. All right, 2 times 5 and 2 times 7. Okay, I have to use every factor at least once, and I have to use them to the highest power possible. So what are the unique factors? 2, 5, and 7. So they're going to be multiplied, but what power of 2? Well, what's the highest power in either one of these? To the first. What about 5? To the first. What about 7? So this is what I'm multiplying to get my answer. What's 2 times 5 times 7? 70 is your LCM. So could you have listed it out? Yes, you would have done 10, 20, 30, 40, 50, 60, 70 at least. 14, 28, 42, 42, 56, 70, and you would have gotten 70. But once those numbers start getting, well, honestly, are you listing out the multiples easily of 14?
But technically it is 0.
Yeah, wow. No, when we say least common multiple, and yes, I kind of made that point, but technically you're saying what's the smallest non-zero number. So.
Then why is 0 part of the list? Well, when it gets
Because there technically is just a multiple, but when we're trying to find the least common multiple, it's saying not 0, because that's not useful for us.
Would there be a number where it is 0?
No. Yeah. Yes, ma'am.
That was my question.
Okay. Unless it's 0 and 0, and I guess that would be 0.
If 5 and 4 didn't have any LCM, wouldn't it be 0?
Well, every set of numbers will have an LCM. That's the cool thing. They will eventually have something out there.
Do negative numbers have an LCM? It is my favorite experiment.
But we're not going to do with negatives. Okay, let's do another one. Let's do number 6, 7 and 9. 7 and 9. Okay, this one's a nice one because they're not too big. And this is going to help you out because this is not the whole point of the lesson, not to find is just to find the LCM. It's to use that. Remember how the lesson said using the LCM? So we're just finding it now, and next we're going to use it. Prime factorization of 7.
7 times 1.
Yeah, 7 times, and you can just say 7 to the first, that's it. The prime factorization of 9. 3 to the second. All right, I'm going to list out, and I'm going to go through this whole process. The unique factors, isn't it 3 and 7? 3 is used the most how many times? Twice. 7 is used the most how many times? You're just multiplying those two together. So what's 9 times 7? Mr. A, couldn't you have just multiplied those two together? Yeah, in this case you could have. But if these numbers get bigger and you just multiply them together, you could find a multiple of the two. But it won't always give you the least one. So that's why we have to be careful. Yes, ma'am.
How come on number 5, it said there were 2 twos, there was 1 and 10 and 1 14.
Mm-hmm.
How come it wasn't 2 to the second?
Good question. So 2 to the second, so right here, right? You're asking how many unique factors and you list them out, and then you ask this next question. How many times is it used the most in either number? So it's used once here, it's used once here, So it's only 2 to the first. And you're going to do that with every single factor, and like you did here. 7 is used the most once. 3 to the second is used the most, 3 is used the most twice, and so you have to multiply those out. Okay, let's do it number 9. If you want to list these out, you may. Just get a big piece of paper and write small. Go ahead, do it.
What's number?
Number 9.
That's not bad at all.
Great.
Go ahead and get the prime factorization, and if you don't know what to do next, just keep it right there. Just get the prime factorization. Yeah, list it out. Yeah, you're fine. No. Don't list it out if you don't want to. Like, that's totally up to you. I would recommend you don't. Oh. Okay, so did you guys get these prime factorizations?
Yes.
Okay, so how many unique factors are there? So there's a 2, there's a 3, there's a, and there's a. Okay, so you guys see we're going to use all those factors at least once. How many times should I use 2? Once. That's the highest time. That's the most amount of times it's used in any one of these numbers. What about 3?
3 to the second.
Twice. Good. What about 5?
Once.
What about 7? Okay, if I multiply these out, I get my LCM. Now, did anyone list them out? Honestly, you listed them out. You list them all out? Or sorry, like you did 45, 90, 135, 180. No one?
Actually, wouldn't have been that hard. You would only have to go to. Because it's not really that
You would only have to go to.
It's only 630.
Yeah.
Only.
Only 630.
Yeah, and what I don't like about the listing, because you do that when you're younger, you do list them out. But if you list them out, and let's say this, you did 45, 90, 125. Let's say you just added wrong the first, that third time, whatever, and then you keep going, you did it right the whole time. You're going to get a wrong answer because you did one addition wrong out of the, 15, 16 additions you had to do. You got one of them wrong, your answer's off. And then, actually, you know what? I'm going to clarify that. It should have been 15 additions, but now you made it more. So now you're all the way out to like 20, 25 additions, and then you still got it wrong. And that would be sad, right? So this right here. Okay, wasted you. All right, 2 times 9 times 5 times 7. And you guys should have gotten 630. Now, how many of you multiplied it left to right? You just did 2 times 9 times 5 times 7. Did anyone multiply differently?
I did.
Okay, Tristan, what did you do? And please listen up.
I did 9 times 7. I got 63.
Okay.
And I did 7 times 5. Oh, 7 times
All right, hold on. Tristan.
63 times 5.
Okay. And then you got something, and then you multiply by 2. You know what's cool? You could do 60. I like your 63. And then you can do your 2 times 5. And then you multiply 63 times 10. 630. So what property was that? 2 of them. Commutative?
Distributive. No,
Associative. I moved this over here. I switched these 2 around. That's commutative. And then I group these and group those, then multiply. So you could do that too. Any order would be fine on these problems. Okay. I want to see if you guys really understand this. So what I'm going to do is this.
Give us the hardest problem.
No, I'm going to give. Well, let's see. It might be hard. It might not.
Give us the hardest one of them.
Number 10. Give it to me.
I can do this.
Don't say it out loud, but give it to me. Don't say it out loud. I don't want the answer out loud because I want people to think about it. This is number 10. The LCM of A and B.
I know. I swear.
Because I don't want this answer. I want the correct answer. So maybe.
That was the hardest problem. Isn't it?
Don't say it. Don't say it.
I actually don't know. Like
Mackenzie. Wait. Yes. Of A and B. You got A, B?
I got one.
I got one AB. I got one A and one B.
Yeah, get it right.
Huh?
I got one.
Yeah. You could have said 1AB.
Or one A, one B.
If you said 1A times 1B, maybe, but then make it simpler.
Oh, God.
But isn't 1 times 1 1? So
Mhm.
if you just AB 1.
So you have to, this is a long way. Listen up, guys. This is not looking good. This is the last warning here. And if it's not, I'm keeping it the same. So if you did the prime factorization, wouldn't you just get A and B? And so how many times is A used the most? Once. How many times is B used the most? Once. So A times B is AB. That's your answer.
1 times 1 is 1. And then
I agree with that.
1.
I agree that 1 times 1 is 1.
Yeah, but it wouldn't be 2 1s. It would only be 1 1.
I kind of agree with that. But anyway, don't get too stressed out about the ones. There were no numbers. Okay. All right, listen up here. What this LCM is saying is this. Ready? This number right here is the smallest number that can fit A and B at the same time. Because we said that there are more common multiples, right? Let me give you another common multiple. A squared, B squared. Can A fit into A squared, B squared? Mm-hmm. Can B fit into A squared, B squared? Yep. But is that the smallest possible value? No. So that's an important figure, and you're going to use that throughout your whole math career. Okay. Let me give you a real tough one here. Okay. Go ahead and do number...
37.
I don't think this one's too tough. Number 32. Number 32. You have 3 numbers. You need to find the LCM of those 3 numbers. Okay, I'm going to call on people, and you may have your hand up, you may not. Sydney, what's the prime factorization of 3a squared?
3 times A times A.
Okay, what's the prime factorization of 6a cubed, Josie?
3 times 2 times A times A.
And what's the prime factorization of 9a to the 4th, Max?
3 times 3 times 8 times 8. Or 3 gets second.
Good. All right, Jensen, what are the unique factors listed out? What are all the factors in these numbers?
3 to the second power. And 2. And 4a.
Are there any other factors? And you're getting the highest power of each. So we got the 3 to the second from that guy. We got the 2 from him. And we got the 8 to the 4th from that third person again. Sorry, gender neutral. All right, so what's your final value for the LCM of 3a squared, 6a cubed, and 9a to the 4th? Caroline. 18a to the 4th is correct. Okay? And guys, this has a huge effect in math. If you can find this out, and yes, soon, guys, you'll be able to do it on your head. Boom, boom, boom. Get it. Great. I'm all for that. But it's good to go through the process again. Okay. Last little part here. It's looking good for time. Go to example number 3. And we're talking right now about least common denominator, which is similar to least common multiple. So look at example 3. And what does it ask us to do in example 3? So please don't read into it what's not there. Therefore, read what it says. Tristan.
Like the direction?
Yeah, just read the bold type.
Which is greater, 5, 6, or 7 ninths?
5, 6, or 7 ninths. Now, some of you are capable of doing this in your head. You're able to say, I know which one is bigger or which one's smaller. But I need you to prove it with math. I need you to prove it and show me. Maybe I don't know. Show me what you did, and you have to write something down. So you're like, do you like draw a picture? Okay. What's the term I just used? Least common denominator, LCD. So look at the denominators, and what you're trying to find out is what is the LCM of 6 and 9. So what's the LCM of 6 and 9? Yes, ma'am? That's the greatest common factor of 6 and 9. Yeah, and see, this is where we have to keep it straight. Yep. 18. 18 is the smallest number that both of these fit into, correct?
Correct.
Okay, so what I'm going to do, and this is what, oh man, if I had time to just talk about fractions for a while, how many of you do not like fractions? Okay, and I'm surprised more didn't say that. Thank you for those who said, didn't raise your hand. And thank you for those who are honest in the pizza form. Listen, I get the fraction like fear or the fraction hate, okay? Fractions, man, who came up with these? Like, why can't you just say 1 and 1.5 or even something closer to 1, whatever? Because this is what happens in life. Like in the class here, if one of you is missing, do I have a full class?
Yes.
No, I would have 19 20ths or 18 19ths. That's what happens. That's what I deal with every day. So we need to be able to deal with fractions. And I wish I had more time. Okay, you guys said the LCD is 18. I agree with that. So what I want to do is I want to change both of these fractions to have a denominator of 18. So watch this. Ready? I need you not only to do it, but you need to tell me why you're allowed to do it. So I'm going to multiply this fraction by 1, by the number 1, in the form of 3 over 3. Isn't that what you guys are going to tell me? Multiply by 3? But you need to be more accurate. If I multiply 5, 6 by 3, I'm going to get 3 times 5, 6. I don't want to multiply by 3. I want to multiply by 1. In the form of 3 over 3. All right, what's 5 times 3? 15. What's 6 times 3?
15.
Okay, when I multiplied by 1, which property was used? Identity, property of multiplication. So ready, guys? 5 6 and 15 18ths are the same exact value. Same exact value. Yeah, and if you had to simplify this when you get 5 6, okay, you can go back and forth. All right. What do you think I had to multiply 7 9 by? Please answer. I take 2 answers. 1 in the form of 2 over 2, or you could say 2 over 2. So what do I multiply 7 9 by? 2 over 2. Please say that, because it means more as you get into harder problems. You're going to say multiply by 2. So I multiply by 2. Ugh, that's not what I wanted. Multiply by 2 over 2. All right, what do I get? What's 7 times 2?
14.
9 times 2?
18.
Now, where at first some of you could have compared these and told me, oh, Mr. Ray, it's so easy. 5 6 is so much bigger than 7 9ths. Now any one of us, which one's bigger? 5 18ths or 14 18ths? Sorry, 15 18ths or 14 18ths? You would say 15 18ths is bigger, which means your answer is going to be 5 6. Okay? Do you guys get why we use LCD? It's because it makes it clear. It's like comparing apples to apples. You've heard that phrase. I've heard it. You don't compare apples to oranges. Or at least not very well. Okay, this one.
Okay, can you
I'd rather you do this because the arch thing is that, except it wasn't clear because now you're like, wait, I thought we did multiply by 3. No, you multiply by 3 over 3, which is the identity property. Okay, let's go with, number 13. Number 13 on top of page 203. I want you to, it says find the least common denominator. No, I want you to find which one is bigger, 3a over 25 or 17a over 20. Oh my, what do I do? Okay, I'll help you out.
A over 20, because you can divide 7 to 20 and get a fixed number.
That doesn't determine whether your number is bigger. Yeah, it does not determine which one's bigger or not. So here I'll help you out. And 17a over 20. Okay. Well, I don't even know what a is, Mr. A. How are you going to figure that out? Okay, I need to get the least common denominator of 25 and 20. So what is it? 100. You guys agree with that? LCD is 100. Sorry. I'm going to show it a little bit differently, see if you guys can remember. What do I multiply 3a over 25 by? Tristan, please answer wisely.
4 over 4.
Very nice. 4 over 4. Do you guys see how this is multiplying? All right, what's 3a times 4?
12A.
12a. What's 25 times 4? 100. All right. Caroline, what do I multiply 17a over 20 by to get a denominator of 100?
25.
There's something missing there. Yeah. Say that one more time. No, you got it. Just say it together because I'm looking for a specific way of saying it. Man, I'm picky. Very nice. 5 over 5. Okay, now here it might be a little bit tough, but what's 17a times 5?
68.
50 plus 35 is 85. 85a. And what's 20 times 5? 100. Which one's bigger?
3A.
So that means this one's bigger.
So I was.
I thought you said that one.
No, I was talking about 17.
But it's a 50-50 guess. I need to work. All right, guys.
But can't you make that one into a mixed number?
Yeah, no, not this one or that one. Neither of them, because the top.
That's funny.
Error. Pause Swivl.